With more and more enterprises adopting Hadoop, one enterprise-level data source that often gets left behind is the mainframe. Mainframes power many mission-critical applications throughout the enterprise, collecting, generating, and processing some of the largest data volumes with exceptional performance and reliability. Many organizations that rely on the mainframe are, at the same time, building data lakes to house all their other important data for analytics with Hadoop. If the mainframe data isn't part of the data lake, a significant piece of the puzzle is missing. The result is that mainframe data is underutilized and the value of the organization's big data investments is diminished. If you have a mainframe, it's critical to bring that data into Hadoop where it can be analyzed along with other important data sources in a cost-effective and scalable manner. By liberating this data from the mainframe, your organization can make better and more informed decisions with previously unattainable insights, significantly impacting growth and profitability. Unfortunately, anyone who has tried to access and integrate mainframe data in Hadoop knows it's easier said than done. The most common challenges include performance bottlenecks on the edge node, which result from trying to ingest the data using FTP and a simple Hadoop put command, the inability to process complex COBOL copybooks with variable length records, which are very common on the mainframe, and the loss of valuable metadata contained within the COBOL copybooks, which occurs when the data is converted out of a mainframe format. This is particularly important for organizations with governance and compliance mandates. Now I'll show you how SyncSort's DMX-h can solve all these challenges and make mainframe data access a breeze in Hadoop. Here, we will create a task that securely connects to the mainframe, extracts the mainframe file, and parallelizes ingestion into Hadoop in its mainframe format. This not only grants extremely low latency extracts, but it also preserves the mainframe data as is exactly as it was on the mainframe, which is a requirement for many compliance initiatives. I've also configured DMX-h to treat FTP connections as FTPS to secure the data access. First, as I select my source, you can see that I am choosing a mainframe variable file. Typically, this causes problems with Hadoop because the record descriptor word causes the file to not be splittable, something that Hadoop requires. DMX-h can handle this with ease, retaining the integrity of mainframe variable data where the same copybook can be used unchanged while distributing the data across the Hadoop file system. The next step is to choose Hadoop as your destination. Again, here you can see that I'm landing into HDFS as a mainframe variable record length file that is Hadoop distributable. Simply select where you want to land the file and you're done. There's no need to complicate the process, just click Run. DMX-h will parallelize the load of the file, bringing critical mainframe data to your data lake to be integrated with other sources from your enterprise. DMX-h makes integration extremely simple as well, allowing non-mainframe developers to work with mainframe data as if it were just another typical data source. For example, with a new task, I can select the mainframe file in Hadoop, apply its COBOL copybook to get its metadata, and I'm ready to go. As you can see, the mainframe variable file that I've selected, while stored in EBCDIC, appears to the developer to be a normal ASCII file. The COBOL copybook I'm using is extremely complex, but DMX-h applies it perfectly. From here, you're able to take advantage of DMX-h to process and integrate mainframe data in Hadoop, MapReduce, or Spark without needing additional Hadoop skills. Learn more by visiting syncsort.com/liberate, or even try it out yourself with a test drive at syncsort.com/try.